Unit 7 review directions. Simplify using exponent rules. Leave no negative exponents in your answers. All right, on number 22, 5x to the third times 8x squared. Remember, we multiply the normal numbers, so 5 times 8 will be 40. And then we get to add our exponents, so 3 plus 2 will give me x to the fifth. All right, the next one, 5a to the negative 2, b to the second, c to the 0, all raised to the third power. First thing that I'm going to do is put a 1 on my 5. If I have parentheses, I'm going to be multiplying my exponents. So I'll get 5, 1 times 3 is 3. A, negative 2 times 3 is negative 6. B, 2 times 3 is 6. And C, 0 times 3 is 0. Alrighty, a few things I can do here. 5 raised to the third power would be 5 times 5 times 5, which would be 125. A to the negative 6, b to the 6, and c to the 0. Anything to the 0 power is 1, so that will just drop out of our problem. And now I'm not allowed to have a negative exponent, so I will move the a term down to the bottom. So I'm going to have 125 b to the 6th over a to the positive 6. When we move it down to the bottom, it becomes positive. Right, 24. X to the negative 2, y to the 8, over x to the 3, y to the negative 4, all raised to the third power. I will work this two different ways depending on which way you work the problem. The first thing I'll do is subtract inside. Negative 2 minus 3 is negative 5, and then y, 8 minus negative 4 is 12, and then it still be raised to the third power. If I multiply, I'll get x to the negative 15, y to the 36. Okay, if I did it the other way, if I multiplied first, I'd get x to the negative 6, y to the 24, x to the 9, y to the negative 12. Now if I subtract, negative 6 minus 9 does give me negative 15, and 24 minus negative 12 does give me a positive 36. So either way we do it, we get the same answer. The x needs to be moved to the bottom because it's negative, so I'll get y to the 36 over x to the positive 15. All right, number 25, x to the 4, y to the 5 over xy to the cubed times x to the 7th y over x squared y to the 9th. I'm going to put some 1s on my x's and y's there. And again, I'll work this two different ways depending on how you like to work the problem. The first way I'm going to work it is subtracting. So if I take 4 minus 1, I'll get x to the 3. And then 5 minus 3, I'll get y to the 2. And then my x's, 7 minus 2 would be x to the 5. And y, 1 minus 9 is negative 8. Excuse me. And then from here, if I add my exponents, I'm going to get x to the 8. And then 2 plus negative 8 would give me negative 6. All right, let's say you went across first instead. So we're going to add our exponents first. We get x to the 11, y to the 6th, and then x to the 3, y to the 12. Now I'm going to subtract. Subtracting, I'll get x to the 8th. 6 minus 12 is y to the negative 6. So you get the same answer either way. We do need to move the y to the bottom, so I'll get x to the 8 over y to the 6th, and that would be my answer. The code letter for this video is N. All right, write an exponential function that would possibly fit each graph below. All right, this one is an exponential function. We do have to use y equals a times b to the x, so don't forget that. This one is touching at 1, 2, 3, so I know that my a value is going to be 3. And then this graph has to grow, so if it's going to grow, the b has to be bigger than 1, so I'm just going to make it 4. You can make it whatever you want. So my exponential function is going to be 3 times 4 to the x power. And notice the biggest thing is the x does have to be in the exponent because it's an exponential function. All right, number 27, again, I'm going to start by writing y equals a times b to the x. This does touch at 1, so my a is going to be 1. And then my b, my growth rate, since my graph is decaying, it's going down. My b has to be a number that is less than 1. So it could be a decimal or a fraction that's less than 1. I'm going to make it 1/3 this time. So I'll have y equals 1 times 1/3 raised to the x power. And again, the exponent has to be the x. You could also write this as 1/3 to the x power. When I check your paper, please make sure that you don't have the exact same example as me. 28. Use the data below and a graphing calculator to find an exponential model. All right, usually we have to check for this, but it does say exponential, so I can automatically know that I'm going to get y equals a times b to the x. And if I'm looking for an exponential model to figure out my growth rate, I'm going to have to backwards divide. So we are going to backwards divide. When I take 122.52 divided by 58.344, we are going to get 2.1. When I take 58.344 and divide it by 27.783, we will get 2.1. When I take 27.783 divided by 13.23, I get 2.1. When I take 13.23 divided by 6.3, I get 2.1. When I take 6.3 divided by 3, I get 2.1. So hopefully it is very obvious to you that my growth rate is 2.1. My A is what's happening at 0, and nicely in this problem we did see what's happening at 0. So my Y value at 0 is 3, so that's my A value. If they did not give you that, we could always just take where we're at and keep backwards dividing until we get back to an X value of 0. So my exponential function for this one is Y equals 3 times 2.1 raised to the X power. Make sure again the X is up in the exponential spot.